All right, now we're going to look at section 4.5. We're going to be graphing trig functions now. So to start, I wanted to just show you a little demonstration. Give me a second here to get it running. Okay. So I want to show you what sine and cosine look like. And in order to do that, I just need you to understand the very basic of the unit circle, how the radius is 1 unit. So going over this way is over 1, so the point 1, 0. Up 1 is 0, 1. To the left 1, and down 1, etc. So what's going to happen is, well, you remember how every coordinate has the first thing is cosine and the second thing is sine? We're going to start by graphing sine. So you're going to want to pay attention to the y coordinate. As this point starts to travel around the circle, watch the y coordinate, because that's what the sine coordinate is. Okay, so the y coordinate is getting bigger and bigger and bigger, and now it's getting smaller and smaller and smaller until the y coordinate is 0. And then now it's negative, getting bigger negative, and then smaller back to 0. So what it's doing is it's taking that y coordinate and it's putting it over here. It's matching the same like length or height, if you want to think of it that way. So now do you see how it's going down below the x-axis? So they're negative, which is negative over here. And then it hits 0 at 2 pi. So this is what sine looks like. This is a sine wave. So it starts at 0. The middle of the graph is 0. And then the very end of the graph comes back to 0. So sine has a beginning, a middle, and an end at 0. It goes up first at pi over 2, and then it dips down at 3 pi over 2. And it kind of has like an S shape to it. Okay, so that's what sine looks like. And again, it's because we're looking at the y coordinates. Okay, now we're going to look at cosine. So for cosine, we're going to be looking at the x coordinates. So now we're looking at the green x coordinate. Well, what they do is with this x coordinate here, this green, they flip it vertically. So it's taking this horizontal like length and flipping it vertically. So cosine has a beginning at 1, halfway it dips down to -1, and then it's going to end up here at 1. Okay, so it started at 1, it's going to go to 0 right there. Now it's heading down to -1. Again, you're looking at those x coordinates. Now it's going to 0, and then now it's going to head back up to 1. Okay, so that's what cosine looks like. If you want to see them both, sometimes people like this. It's very hypnotizing, calming. Okay, so I'm going to stop it then. All right, so we are going to learn how to graph these by hand. So what I want you to get used to is the idea that all we're really using is the point 1, 0, the point 0, 1, -1, 0, and 0, -1. And those points happen at 0 radians, at pi over 2 radians, at pi radians, and 3 pi over 2 radians. So whenever I graph a trig function, I make 4 tick marks. And those 4 tick marks correspond to these 4 right here. Okay, now again, when we're graphing sine, we're only going to focus on the y value. So at 0 radians, the value of sine is 0. At pi over 2 radians, the value of sine is 1. At pi radians, the value of sine is 0 again. At 3 pi over 2, the value of sine is negative 1. And then going back to 2 pi, the value of sine is 0 again. So if I plot that on this graph, 0, 0, pi over 2, it goes up to 1. At pi, it goes back to 0. At 3 pi over 2, it goes down to negative 1. And at 2 pi, it goes back to 0. Now when you connect the dots, make them like a roller coaster, curvy. Okay, we don't want any sharp turns, we don't want any V shapes or anything like that. Make it look like a wave. Okay, so what you need to remember with sine is it has a beginning, it has a middle, and an end at the same place. In this case, it's at 0. You could draw a horizontal line through all 3 of those dots. Sine goes up first, and then it goes down second. Okay, let's look at cosine. So again, we're using those same points. 1, 0, 0, 1, negative 1, 0, 0, negative 1. And we're going to go according to those angles, 0, pi over 2, pi, and 3 pi over 2. This time we're going to look at the value of cosine. So cosine is the first one listed. So at 0 radians, the value of cosine is 1. At pi over 2, the value of cosine is 0. At pi, the value of cosine is negative 1. At 3 pi over 2, the value of cosine is 0. And back to 2 pi, the value of cosine is 1. So if we graph that, we start up at 1. At pi over 2, it goes down to 0. At pi, it goes down even more to negative 1. At 3 pi over 2, it goes back to 0. And at 2 pi, it goes back up to 1. Now I know that these dots look like a V, but don't connect them like a V. These are not V's, these are curvy like waves. So make it like a curvy wave. Okay? Now this is just one period. These things continue on forever and ever and ever. So this would continue to the left and this would continue to the right. This is just one chunk of the graph. We call it one period. Same with sine. This would continue on. So this would keep going like that. This would keep going like this, and then it would eventually curve back up again. So they do go on forever. It's just that we only graphed one period, like one time around the unit circle. Other little corny thing is, do you see how the sine kind of looks like an S shape? And cosine kind of looks like, like some people say if you take a C and you turn it on its side, that's kind of what cosine looks like. You could also say it looks kind of like a cup. I don't know if you want to envision a cup. It's got that kind of dip to it. Okay, whatever you want to remember that. Okay, now you're gonna see with the formulas some extra stuff. So like we just did just plain sine x. Well, you might have some extra numbers in front here, and you might have some extra numbers in front of the x. If there's a number in the very, very front, that's responsible for the amplitude. The amplitude is how high up or how far down the graph goes. And this is going to be responsible for vertically stretching or shrinking. If you get a negative value for A, that's a flip over the x-axis. So we'll do an example of the amplitude in a minute here. This value of B in front of the x, directly in front of the x, that value of B changes the period. Now, let's go back here. How long is one period? So how long does one chunk span? One chunk spans 2 pi. Again, because it was one time around the circle, which is 2 pi. Same thing with cosine. Cosine starts here, and one period spans that distance, which is 2 pi. So that's a typical period, but if you have a value of b right here in front of the x, that's going to change the period. So you're going to do 2 pi divided by b, and that is going to be your new period. It's going to be how long one interval of the graph is. This is horizontal stretching and shrinking. So, for example, here we've got a 2 that's out in front. That's the amplitude. Our amplitude in this case is a 2. If we want to find the period of this graph, we're going to take 2 pi and we're going to divide it by the value of b. The value of b is 1/3. Okay, so instead of dividing by a fraction, I'm going to multiply by the reciprocal. So now the period is 6 pi. Okay, so what that means is now when you go to graph this thing, I'm always going to make 4 tick marks. The period, whatever the period is, that will be the last tick mark. Okay, so here's my little trick on how to label these, because that's usually the trickiest thing, is how to label these. I find the halfway mark. Half of 6 pi would be 3 pi. Then I find half of the half. Well, all you have to do is take the 3 pi and divide it by 2. That would be half of 3 pi. Now for this tick mark, this usually gives people some trouble, this third tick mark. All I do is I take the first thing, whatever it is, and multiply it by 3. So if I take that first tick mark and I multiply it by 3, which is technically 3 over 1, I'm going to get 9 pi over 2. That's what this one is labeled. Okay, so to recap, when you get a change in the period, that's going to be what you label your fourth tick mark as. Okay, and then you have to figure out how to label these other 3. We'll do more examples, okay? All right, so I just want to reiterate cosine. Okay, so make your 4 tick marks. Period of cosine is just 2 pi. Go to the halfway mark. Half of 2 pi is pi. Half of that is pi over 2. And then I take this first tick mark and I multiply it by 3. 3 pi over 2. Okay, so cosine always starts up high at 1, and it always ends up high at 1, and halfway in the middle it dips down to -1. And then it has to cross through 0 to get down there, and it has to cross through 0 to get back up here. And again, make it as like curvy as you can, not like a V shape. Okay, so that would be regular cosine. Now what we're going to do is we're going to change it by this amplitude of 3. So what that's going to do, actually I think I'll graph it on the exact same graph here. Just give me a second. I'm going to fix this. I'm going to get rid of that graph. And I'm going to shift this whole graph down a little bit. Okay, so what an amplitude of 3 does is it's going to make this top of the bump stretch up to 3, and it's going to make this bottom dip down to -3, and it's going to make this stretch up to 3. So I need to add on a little bit to my picture. Okay. So all it does is it stretches the top of the bump up to 3. This will still be at 0. This bottom of the bump will stretch down to -3. This will stay at 0. And this top of the bump will stretch up to 3. So now when I connect the dots, okay, what I got now is my red graph got stretched vertically. It didn't change horizontally or anything like that, just vertically it's stretched. It didn't shift up or down, just stretched. Okay. Okay, let's look at another example. This time, I have a value in front of the x. That's the b value. That's responsible for changing the period. So in order to get the new period, you take 2 pi, because that would be a regular normal period, and you divide by the value of b. So we're going to divide by 2. Okay, those 2's cancel, so we get pi. That's the period now. So again, make 4 tick marks. Whatever the period is, that's the last tick mark. So the last tick mark is pi. Okay, it's just me, but I go to the middle because half of pi is pi over 2. Half of that, half of a half is a fourth, so this would be pi over 4. And then I take whatever this first tick mark is and I multiply it by 3 to get the third tick mark. So pi over 4 times 3 is 3 pi over 4. If it helps you, this is 1/4, 2/4, 3/4, 4/4. Okay, and then cosine, the amplitude is still a 1, so it's going to go up 1 and down to -1. Cosine always starts up high at 1 and it always ends up high at 1. Halfway in the middle is where it dips down, and then it has to cross through 0 to get down to here, and it has to cross through 0 to get up to here, and then connect your dots. Okay. With the next one here, the value of b is 1/3. So this period, you're going to take 2 pi and you're going to divide it by 1/3, which is the same as taking 2 pi and multiplying it by 3 over 1. So we get 6 pi. That's the new period. So make your 4 tick marks. The last tick mark is whatever the period is. Halfway to 6 pi is 3 pi. Divide that by 2, you get 3 pi over 2. Take this first tick mark and multiply it by 3 to get the third tick mark. So 3 pi over 2 times 3 is 9 pi over 2. The amplitude is still 1, so we're going to go up to 1 and down to -1. And then now we're going to draw in our graph. So again, cosine starts up high at 1 and it ends up high at 1. Halfway is where it dips down to -1, It has to cross through 0 to get there and there, and then connect the dots. So hopefully what you're noticing is these graphs look the same, don't they? Just the blue part of the picture looks the same. But the most crucial part is how you label. The labeling of the x-axis is what makes these completely different. So labeling is an absolute must. You must label every tick mark. Okay? Even on the y-axis, you have to label 1, -1. You can't just make a tick mark and have me assume it's going to be 1. I'm not going to assume anything. Okay, you've got to label every single tick mark. So, what I want to say then is if you're doing your homework and this is what your homework looks like, that is not going to count. This is complete and utter crap. I'm not going to give you credit for that. I'm not even going to give you credit if you like make your tick marks, but then don't actually label them. That's also not any good. Okay? So all of these are terrible. Don't do them. Make sure that you label every tick mark. Okay? If you come and talk to me next week and like you don't have your tick marks labeled, I'm going to know that you didn't watch this video. Okay? Actually, I want to go back and I want to compare so you can see a little bit better what regular cosine would look like next to this, for example. Actually, no, we'll do regular cosine compared to cosine 2x. Okay, so we'll do regular cosine compared to cosine 2x. And I'm going to put them both on the same graph just so you can see it a little bit better. So cosine 2x, actually no, cosine x, we'll start with that one. It goes pi over 2, pi, 3 pi over 2, 2 pi, up to 1, down to -1. Okay, so here's what regular cosine looks like. Starts and ends up at 1, halfway in the middle dips down to -1, crosses through 0, so it looks like that. Okay, do you remember back when we did cosine 2x, how the period was pi? This U shape had to fit in the span from 0 to pi. That U shape had to fit between here and here. Okay, so we had 4 tick marks. 1, 2, 3, 4. Remember how this one was labeled pi over 4 and this one was 3 pi over 4? And we started at 1, went through 0, down to -1, went through 0, and then back up to 1. So if I drew that in, that's what cosine 2x would look like compared to just cosine x. The period shrunk. It shrunk from 2 pi to pi. Here, go back. Remember how that period changed to pi? So the period shrunk. We had to fit this U shape into a shorter period. Okay, so it all looks nice when you put them on the same graph, but what's going to happen when you do your homework is they're going to be all separate like these. So they're all going to end up looking exactly the same. The only difference is how you label. That's why you got to label every single tick mark. Okay, let's look at sine real quick here. So again, if I'm going to graph just plain sine, it goes pi over 2, pi, 3 pi over 2, and 2 pi. Okay, just regular sine has an amplitude of 1. Sine has a beginning, a middle, and an end at 0. It bumps up to 1 first, and then it dips down to -1 second. So sine looks like that. Okay, now if I change the amplitude to 2, then I have to add onto my graph. So now the bumps are going to bump up to 2 and the dips are going to dip down to -2. But everything else stays the same. The beginning, the middle, and the end still stay at 0. But now it's just stretching up and stretching down. It's a vertical stretch when you have an amplitude change. When you have a period change, okay, when that value is in front of the x, that's the b value. So the period will now be 2 pi divided by b. So it'll be 2 pi divided by 2, which just simplifies to pi. So again, 4 tick marks. The last tick mark is whatever your period is, so pi. Halfway would be pi over 2. Half of that is pi over 4. Multiply the first tick mark by 3 to get the third tick mark. Okay, this has an amplitude of 1, so we're just going to go up to 1 and down to -1, and then draw in your graph. So again, it has a beginning, a middle, and an end at 0. It goes up to 1 first, and then down to -1 second. And then connect the dots as best as you can. Okay, and again, make sure it looks like a curve, not like V's or anything. Okay, this one has 2 aspects to it. It's got an amplitude of 3, and then it has a value in front of the x. Technically, what's in front of the x? Technically, it's a 1/2. So the b value is 1/2. So to get the period, we have to do 2 pi divided by the value of b, which is 1/2. That's the same thing as 2 pi times the reciprocal. The reciprocal of 1/2 is 2 over 1. So the period is 4 pi. Make your 4 tick marks. The last tick mark is the period, so the last tick mark is 4 pi. Halfway, half of 4 pi is 2 pi. Half of 2 pi is 1 pi. Multiply that tick mark by 3 to get the third tick mark. Makes sense, right? 1 pi, 2 pi, 3 pi, 4 pi. And again, the amplitude is 3, so I need to make sure that my tick marks on the y-axis go up to 3 and go down to -3. Okay, and then you just need to remember that sine always has a beginning, a middle, and an end at 0. It goes up first and it goes down second. And we remember we have to go up to 3 and we have to go down to -3. Okay, because the amplitude was 3. And the graph was sine. That's why it has a beginning, a middle, and an end at 0. Bumps up first and dips down second. Okay, this one might be our last one. Let me just double check. Yeah, we'll probably do this one as the last one. So do you see the negative sign right here? That's going to be a flip over the x-axis. So keep that in mind. Technically, the amplitude is a 1. So our tick marks only need to go up to 1 and down to -1. The value in front of the x is pi over 4. That's the value of b. Seems a little weird, but go with it. So the period change, we do 2 pi divided by b. So in this case, 2 pi divided by pi over 4. Take the 2 pi and multiply by the reciprocal, which is 4 over pi. In this case, the pi's cancel, so we just get 8. The period is 8. Make your 4 tick marks. The last tick mark is whatever the period is. Half of 8 is 4, half of 4 is 2, 2 times 3 is 6, 2, 4, 6, 8. That makes sense. Okay, now I know I'm going to need to flip, but before I flip, I'm just going to graph cosine with this amplitude of 1 and this period of 8. I'm just going to get a feel for what cosine looks like. So cosine usually starts up high and ends up high, and it dips down in the middle, and it has to cross through 0 to get there. So this is what cosine would normally look like. Okay, but now for my final graph, I'm going to flip over the x-axis. So this 1 is actually going to flip down here to -1. 0 is on the x-axis, so it just stays there. This flips up to +1. 0, again, just stays there. And then this flips down to -1. So now the flip over the x-axis would look like this. Okay, and again, that's 1 period. All I'm going to require you to do is just 1 period for now. Okay. I think we'll stop there. Okay. So now you can have some time during class to work on the 4.5 homework. And I will see you on Monday. Have a good weekend.